Next problem, a smooth 2 kg collar as shown in figure is allowed to move on a vertical shaft if the spring is unstretched when collar is at position A. Determine the speed of collar at B if, first case, it is released from rest at A. It is released at A with upward velocity of 2 meter per second, right? So what is given in this problem? A smooth 2 kg collar. So this is the collar, okay? So it is given smooth, so it is allowed to move on a vertical shaft. This is a vertical shaft, okay? So it is moving along this vertical shaft, okay? So if the spring is unstretched when collar is at position A, okay? So here when the position of collar is here, so this is the original length of this spring, that is 0.75, okay? So when this is at the B position, so this is a stretch position, means there is a deformation in the spring, okay? So we need to find the speed at collar B. So at this location, when this travel from this to this, we need to find the speed at B. So there are two cases given. If it is released from A and it is released at A with upward velocity, means we throw this up with the velocity of 2 meter, then it will come down. So at that time, what is the speed that we need to find, okay? Now first of all, we need to consider the type of forces here, okay? So as it is given here, a smooth 2 kg collar. Smooth means there is no friction, okay? So there will be no friction force. So here it is a spring, so there will be a spring force. As it is coming down, so there will be a gravity force, okay? So we will calculate the work done under gravity and work done by the spring force, okay? So first of all, we will find the deformation, okay? So at A, spring is unstretched. So what will be XA? So XA is the deformation in the spring. So it is 0 meter. So at this position, so there is no deformation in the spring. So XA is equal to 0 meter. Alright. Now at B, it is stretched. So we need to find the deformation. So how to find the deformation at B? So here it is length of collar, so length of this 1 meter. Here it is 0.75 meter is given, and we need to find this, okay? So you can find this using the Pythagoras theorem. So suppose this, consider this as a L, okay? So what is L is equal to? L is equal to under root 1 square plus 0.75 square. So 0.75 square plus 1 under root answer. So we'll get 1.25. So this total length is 1.25 meter, okay? But original length is what? 0.75. So XB, deformation when this is at B, is equal to 1.25 minus 0.75, okay? So it is 0.75, sorry, 0.5 meter, right? Now we will find work done by gravity force and work done by the spring force, right? So the first work done by gravity force. So what is the formula for work done for the gravity force? So work done by force of gravity from A to B, okay? So it is given by mgh. So right, So what is mass here? Mass of the collar is given 2 kg, right? Gravity is 9.81 and height is 1. So it's 2 into 9.81, so 19.62 Newton meter. So this is the work done by the force of gravity. Now the second, work done by spring force. So work done from A to B by the force of spring. So it is given by 1 by 2 into spring stiffness K in bracket XA square minus XB square, right? So 1 by 2. What is spring stiffness given here? It is given 3, K value 3, right? So XA, it is 0, we got 0 minus XB 0.5 square. Okay, so by solving this you will get 0.5 square into 3 divided by 2. So minus, it is minus 0.375 due to this Newton meter. Okay, so this is the work done by the spring force, that is minus 0.375 Newton meter. Now case 1. Okay, so it is allowed to throw from, it is allowed to fall from A to B. Okay, so in that case we need to find the velocity at B. So by using work energy principle. Okay, what is work energy principle? Total work done is equal to change in kinetic energy. So this is the work energy principle. So what is total work done? So force of gravity plus work done by force of gravity plus work done by the force of spring. Okay, so gravity work is 19.62 minus 0.375, it is the spring force work. Okay, is equal to change in kinetic energy, that is 1 by 2. So change in kinetic energy at B minus kinetic energy at A, which is equal to 1 by 2 mvb square minus 1 by 2 mva square, right? So 19.62 minus s, okay, so it is 19.245, right? Then 1 by 2 mass is 2, right? And vv square we need to find 1 by 2 into mass 2 va. Okay, it is released, means initial velocity, this va at this it is 0. Okay, so this all turn to be 0, 2 get cancelled, so we get vv square is equal to 19.245. okay, so what is vb? Vb is equal to under root 19.4245. okay, so we got vb value 4.38 meter per second square. This is case first. When we release this from A, okay, so we get vb is equal to 4.38 meter per second. Now case 2. So what is given here? So va, velocity is given, va is given 2 meter, which is in upward direction. Okay, now again using the same work energy principle, using work energy principle, that is total work done is equal to change in kinetic energy. Okay, so total work done we have found it here, that is 19.245. change in kinetic energy, that is Here you can see this 1 by 2 mvv square minus 1 by 2 mva square. I'm directly going to write, so into 2 vb we need to find it, minus 1 by 2 into 2 v8 is given here 2 square, right? So this 2 get cancelled, here 2 get cancelled, so 19.245. okay, here it is 4, so plus 4 is equal to vb square, so is equal to 23.245. so vb is equal to under root 23.245, so we'll get 4.821 meter per second. So this is the answer of velocity of B, velocity at B, that is 4.821 meter per second in case 2.